Okay, so yesterday we talked about shortcuts, 2 new shortcuts, right, to proving that triangles are congruent. What are the 3 shortcuts we know as of now? Side, side, side. Side, angle, side, and hypotenuse, leg. Okay. So this one says state a third congruence that would allow you to prove triangle RST is congruent to X, Y, Z by side, angle, side congruence. Lewis.
Angle S is congruent to angle Y.
Angle S is congruent to angle Y. That's hard.
Is it okay if we put angle RST?
Sure. As long as, so angle RST
Is congruent to
X, Y, Z. Yep. And then 4 said angle T is congruent to angle Z. And RT is congruent to XZ, which means what's the other piece of information you would need, Gio?
ST is congruent to YZ.
Good. Or TS to ZY, order there doesn't matter.
You know the angle side angle one that
Today? Yeah.
I thought about that yesterday while doing homework and thought I just invented it. And then I went forward in the notes.
And you saw it already there. So smart. Okay, any questions on the 3 we already have? So again, we're going to add to this today. By the time test rolls around, you're going to have 5. But we're going to, but for right now, any questions of side, 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 angle, side, or hypotenuse, leg?
Well, we're doing 2 more today.
34. Now this was one that they gave you the partial fill-in. If you could go back and do this empty, okay, it's gonna be like on your test, so keep that in mind. So it says that M is the midpoint of LN. It says that triangle M or PMQ is isosceles with MP equal to MO. And angle L and angle N are right angles, so those are marked, okay? So all that information is given. This one's given, and this one's given, and this one's given. Then it says that triangle LMP and triangle NMQ are right. Because you have the right angles there, you know they're right triangles, which would be the definition of a right triangle. Then you go to the midpoint, so then you say that this is congruent to this. That would be the definition of the midpoint. And then you get your last given, and then you've got your triangles are congruent because of hypotenuse, leg. They have to be right triangles, you have to have the hypotenuse congruent, and you have to have the leg congruent. 26 is blank, so a little bit more on level with what you're going to see next week. This says that Vx is congruent to xy, so Vx. And xw is congruent to yz. Xw, yz. Those are given. And also that xw is parallel to yz. All right, so if we have side, 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 side angle, side, and hypotenuse leg to choose from, what can you rule out right away? Hypotenuse leg, there's no right angle. And I know nothing about that other third side, right? So I'm going to have to use side angle, side. What piece of information do you already have?
You already have 2 sides.
You've got the 2 sides. I need it to be the included angle, so I basically have to prove that this angle is congruent to this angle. How do I do that? Good. If those lines are parallel and this is my transversal, then angle VXW is congruent to angle XYZ because corresponding angles postulate. If you don't remember the name, then you write it out. If parallel lines are cut by a transversal, corresponding angles are congruent. Now, do you have enough information to prove that the triangles are congruent? Yep. Triangle VXW is congruent to triangle XYZ. Connor. Okay, this one says PQ bisects angle SPT and SP is congruent to TP. What does it mean to bisect something? Cut it into 2 equal parts. So if this is bisecting this angle, then this one and this one are equal, right? So I can say that angle SPQ is congruent to angle TPQ. And that's the definition of the angle bisector.
Can't you say PQ
Yep. What's that?
Reflection. And then that's all you have to do, right?
Mm-hmm. So this would be here. Questions? Any other questions on homework? All right, let's learn some more shortcuts. Right, we like the shortcuts. 2 more today, which is the last 2 for triangles. Chapter 4, section 6 is angle, side angle, and angle, angle, side.
And when's the test?
Your test is Thursday,
Thursday?
a week from yesterday. Angle, side angle, and angle, angle, side. All right, so the first one is angle, side angle. Sure.
I like that thing.
Sure. Whatever it is that you discovered yesterday.
Stand up.
Come on.
Oh,
I can't point to.
serious about it. Should we get our cameras out?
No. Go for it.
I thought I discovered this, but I was wrong. So I saw that it was a thing already. So, if you have one segment and you know it's congruent to another triangle, then you can already assume that, well, you can't assume, and then you know that these 2 angles are part of that segment are congruent to these 2 angles. Then it's impossible for the lines to be changed because these are congruent to those.
Yep.
And it doesn't matter the length of these because it's still going to make a triangle. So like if this is just greater than this, it's just going to keep going, but you're still going to have a triangle that's the same as that one.
Good. So, people like Lewis at some point in the history of geometry discovered that if I had like these specific things, there was no way to make any other triangle that shape, right? That's where all these things come from. So if I had given all of you a little, let's say a toothpick, a certain length, and I said this has to remain this length, and then I said the angles off of it have to be these angles, every single one of you would make exactly the same triangle. That's the idea. There's no way to make a triangle that is different from these if I give you a specific side and then the angles that come off the other side. So the thing is, like, if I want to make this a longer side, then this side would have to come out, which would then affect that angle. Does that make sense? So that's why these things, these acronyms, it's not like they just make them up, right? They come to fruition because this is a fixed triangle. So this one's called angle, side angle. The order of the letters is important because the S has to be the included side. So yesterday we talked about included angles and included sides. The included side has to be the side that connects those 2 angles. So if I have this angle and this angle, I have to have the side that connects them. Same thing here, this angle and this angle, it has to be the side that connects them, okay? And then this triangle ABC would be congruent to triangle DFE, and my reason is angle, side angle. Wait, I switched this. DEF. Right, order of the letters is important. Okay, last one is angle, angle, side. So this is AAS. Now notice the S is not in between. The S is not the included side. So you've got 2 angles and the non-included side equals 2 angles and the non-included side. So in this diagram, I could say that triangle GHJ is congruent to triangle KLM, and my reason is angle, angle, side. So that's it. There are 5, okay? And it's because with these specific requirements, you can only make 1 triangle. You can't invent other ones. So there's no ASS or SSA, and it's not because it spells a bad word. It's because it wouldn't work. It's because I could give you 2 sides and a non-included angle, and you could make different shaped triangles, okay? So think, if you're writing a bad word on your test, forwards or backwards, it's wrong. It's not an acronym that works. SSA or ASS.
I get ASS or whatever, but SSA?
Oh, I thought you were like, that's what that. Oh, no.
Okay, so we've got side, side, side. We've got side, angle, side. We've got hypotenuse, leg. We've got angle, side, angle. And we've got angle, angle, side. These are the 5, okay?
So there's no
That's
side
it?
side angle.
There's no side, side, angle. Or angle, side, side. And not because it spells a bad word, but literally if I gave you two toothpicks, right, and said, connect those in any way, but one of the angles that comes off them has to be this, you can change the shape. So you can make a different triangle than Matt makes because it's not a fixed length. Does that make sense? Yeah.
So ASA and AAS both are like the two angles that are
Both
congruent?
require 2 angles and one side, but one is the side where the 2 angles meet, and one is not that.
What were you saying about like how we can each make like the same triangles?
That's what these are. So like if I gave you 3 pieces of string, every single one of you got a piece of string that was 2 inches, 1 inch, or 2 inch and 3 inches and 3 inches, let's say. Every single one of you would make the exact same triangle. There's no way to make it any other way. If I give you 2 sides and I say where those sides meet has to be this angle, every single one of you makes the exact same triangle. But if I give you 2 sides and then I say put these 2 together, right? And any angle you want, because it's not where those meet, then you can make different triangles, which is why side-side angle does not work. So these are theorems that prove triangles are congruent, because when you are given those specific requirements, there is exactly one and only one triangle that can be made.
Okay.
Does that make sense?
Yeah.
Whereas if I just gave you 2 sides and said, put them together at any angle, but then form the angle off of one of those sides, because it doesn't even have to be both, just one of those sides at this angle, then you could make a totally different triangle than what Anna makes. Can make a totally different triangle than what Mateo makes.
So like both of the angles have to be the same.
Correct. Well, or the one where they meet has to be the same, which would be side, angle, side. So does that make sense?
Yeah.
If I gave you 2 side lengths, then the angle in between them is what's going to fix it to it. Okay. All right, so this one kind of just summarizes it all, right? It says the triangle congruence postulates and theorems, okay? All 5 methods are here. Side, 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 where all 3 sides are congruent. Side, angle, side, where 2 sides and the included angle are congruent. Hypotenuse, leg, where it has to be a right triangle. The hypotenuses have to be marked as congruent, and then one of the sides. Angle, side, angle, where it's 2 angles and the included side, and then angle, angle, side, where it's 2 angles and the non-included side.
So if it's congruency mark for angle and the side was swapped to EF,
For which one?
for angle and side,
Yeah.
would it still work?
If it was C and F?
If it was E and F, would it still work?
If the angle, if you're saying instead of having this one, it was this?
No, I mean like to the
No,
right.
he's talking about the segment, the part.
Yeah.
Oh,
It was EF instead of
I got you. If it was here and here instead of here and here, that would still work because it's still 2 angles and the non-included side. Yeah, as long as it's not the one in between. Questions? So now think about what you're doing. Obviously, we're going to be proving a lot of these things, right? Now, if you get a proof and the proof statement is that 2 triangles are congruent, now you've got 5 things to choose from. From those 5, you've got to figure out what information you have that makes sense with one of those. Okay?
We have 6 because the definition of congruent.
Yeah, but you're going to use a shortcut before you use that, right? Okay, so this one says, given that angle X is congruent to angle V, angle XYZ, or XYW, sorry, is congruent to, this one is, what I knew there's one wrong on here. This should be VYZ. Yeah. And XY is congruent to VY. Prove triangle X, Y, Z is congruent. Did I change the wrong one? To VY. Y, W.
Pardon the interruption.
No.
Lauren Kim.
I'll show you how it works.
Services. Lauren Kim, please report to student services. Thank you.
Shouldn't the angle be down more though? Shouldn't it be like Z?
Say again?
Shouldn't the angle be like Z because Z's in the middle? That's what I mean.
So, but we can get there from this.
Oh.
We just have to, it's not just the given and the proof. We got to do a little bit of work. So first of all, make that change so that it should be, instead of Y, W, Z, it should be V, Y, Z. Okay? And then I marked everything, right? No, I didn't mark. Oh, yeah, I did. Okay, I didn't write out the given. Angle Y, Z, W, V, Y, Z, and X, Y to V, Y. All that's given. Okay. So think about what you're trying to prove. Obviously, two triangles are congruent. Think about your bank of possibilities. Side, 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 angle, side, hypotenuse, leg, angle, side, angle, and angle, angle, side. What piece of information do you already know about? Look at the blue and the green triangles because that's what we're trying to prove. What kind of information do you already know? You're both right. You've got the angles that are X and V, right? This one. So you already got one pair of angles. And you've got this side here. So I've got one pair of sides. From that, I should probably rule out side, side, side. Because if I've got information about sides, it's not that one. I should also probably rule out what?
Angle, wait, isn't it
Hypotenuse.
Hypotenuse leg, because it's not a right angle. It is not angle, side, angle yet. Because what's happening at the top? It's telling you that whole thing is congruent. It's saying that this whole thing is congruent to this whole thing. And I need to get just this and this.
So you have to put like angle addition plus.
Yes, sir. Good job. So I've got to take away the part that overlaps, right? I have to take this part of the angle away. And to do that, I have to say that the big angles are the sum of the two smaller parts. And then I got to take away the part that overlaps. So I'm going to say that angle X, Y, W equals angle X, Y, Z plus Z, Y, W plus, yep. The big one is the sum of the two smaller ones. And then Z, Y, V equals Z, Y, W plus W, Y, V. And that's the angle addition postulate. Now, I already said that this equals this. I said that this equals this, which means this one equals this one. So X, Y, Z plus Z, Y, W equals Z, Y, W plus W, Y, V. And that's substitution. Now, what did we say is the overlap?
The overlap would be the Y.
This angle here, the yellow angle is that Z, Y, W, right?
Mm-hmm.
It's on both sides, but before I can subtract it off, what do I have to say? That it equals itself. And what is that?
Triangles overlap.
No, when an angle is part, that what we're trying to take away is part of both of them. Yep. And then I can say X, Y, Z is congruent to W, Y, V. And that's the subtraction property of equality. And then the triangles are equal. Because I just said now these equal these. And that's
ASA.
good. Yep.
Could you also do side angle side? It's like XZ and W.
But you don't know anything about those lengths.
Oh,
Wouldn't everything be wrong?
Not if you go off of what we marked and not what the statement said.
Okay.
Like, so if you go off of what we marked, then it should be like that.
Mark a lot.
But we marked it wrong. Yeah.
I have the next.
Okay, good. So actually,
Erase everything and then copy?
but then you can also do it that way.
Ma'am, how do you duplicate a slide?
Okay, so now we're gonna mark it the way that it's supposed to be. X and V, and then Y, Z, W, and Y, W, Z. Yes.
On the inside.
I'm gonna get it right at some point today. Just you wait.
Why is it
Y, Z, W,
It's a different question.
X, Y, Z.
and Y, W, Z. Thank you. And then X, Y, and V, Y. Okay, but still the same goal. The goal was to prove this triangle is congruent to this triangle. Okay, good. We just talked about this, the linear pair postulate, yes, right? These two have to add up to 180. These two have to add up to 180. Then you can set them equal to each other, and then you can subtract off the congruent part. Yes? So the given,
And then angle, A, B, do angle side.
and then I can say angle X, Z, Y plus Y, Z, W equals 180. And V, W, Y plus Y, W, Z equals 180. And that's the linear pair postulate. And then because they equal 180, they equal each other. That's so sloppy, but you know what that is. That's substitution.
And then you subtract the ones that are.
And then we already said
Substitution is big.
that this part, Y, this part, and this part are congruent, so we can take it off. It's the subtraction property of equality. So then I'm here, which is what?
I'm so confused by that. Yeah, oh.
Why are they congruent?
What's so funny?
I don't know.
I just like.
Angle, angle, side. Okay, Lewis, give me.
I did mine with I'm glad. This one? I'm glad.
You have them both together? Do you have them both together like that? Okay. All right. So everything's marked that's on there, right? So now what?
LJ is congruent to angle LJ.
Because this is bisecting this angle, right?
Definitely.
So KLJ. What's your reason?
Definition. I did KLJ. That's good to know.
KLJ.
It doesn't matter if you put J amount and.
I did that too, yes.
Yeah, okay.
And then LJ.
That's definition of angle bisector, right, though? Yeah, right? Or bisector, because it didn't say angle bisector.
Yeah, that's.
Then what?
I put midpoint, but it is that.
Right.
And then LJ is congruent to LJ, the flexor. And then triangle JKL is congruent to triangle JML and angle side. Oh.
Good job. So 2 and 3 didn't have to be in that order. You could switch 2 and 3, right? But you needed both of them to get to the end. Connor.
Could it also be, oh wait, never mind.
My advice is as soon as you see shapes, look for things like reflexive sides, vertical angles, those things that are easy that should be coming quick to your mind, you want to identify right away. How many of you got that one right? Okay, good. All right, 3, identify the postulate or theorem that proves that they're not long proofs. This is a yes or no and a which postulate. So take a deep breath before you start whining. Theorem or postulate. Some of them are postulates, but you just need SSS. I think it's side, side, sides, postulate. All right, so number one, you've got that this one equals this one, and this one equals this one, and the side between. Are these two congruent?
Yes.
And why?
Angle, side angle.
Angle, side angle. Two, you've got 90 degrees, the two bottom sides, and then the ones across from the 90 degrees. What is this? Hypotenuse leg. So be careful. Remember, that would technically be angle, side, side, which is not a thing. It has to be a right angle, which makes it hypotenuse leg. Yep. No. This, you mean? If you prove that, yeah, so if you go the extra step and do that, then you can do side angle side. But based on what it's given, it's hypotenuse leg. Does that make sense?
But can it be side too?
It could be, once you get that, it could be side. So if you add in the reflexive side, it could be side, side, side. It could be side angle side. But from the get-go, it'd be hypotenuse leg. Number three,
You got vertical.
you got vertical angles.
Side angle side.
What else could it be if you prove the side? Again, side, side, side. Okay, can't be anything else, right? Because we can't do angle, side, side. Questions? Yep.
Is this like the one on the homework? There wouldn't be enough information, right? Or like, would that be considered vertical?
That would be vertical angles. Yeah. So sometimes you get more than one answer, like these. And it could be more than one answer. Same thing, like for a test, you might end up finding that it could be this or that.
So how would you know when you can like use things like that?
Every time it's information that's given from the diagram, you can use it. All right, last one. This is the one that has the typo.
Wait, really? I wrote it.
Really?
Wait, where's the oh yeah.
FAB, GED, ABC, EDC, or CDE, and AC and CE. Okay, now what? This is actually going to help us with the first one that we messed up that I messed up, that I'll go back.
Oh, you do linear pair.
You can do a linear pair. So these two angles form a linear pair, right? These two angles form a linear pair. So angle FAB plus angle CAB equals 180. CED plus GED equals 180. That's the linear pair postulate. Then you set them equal to each other. Yep, I'm listening. What?
Then you can do subtraction, right? Because
This-
they're equal.
But so then what's in common here that I can take away are the angles that were originally marked, which is the FAB and the GED, FAB, GED. I already said they're congruent, so I don't have to say they're congruent again. That was already in my given, which means I can just subtract them off. CAB, CED, subtraction. Property of equality. Now I just said that these are congruent,
This would be angle side.
which is angle, angle, side. Good.
We subtract subtracted them because they're equal to each other.
Because of the same, yep. It's very specific.